Welcome to this BeeGraphy tutorial. In this video, we'll explore the possibilities of computing design on the cloud. We'll learn how to create a dynamic, wavy surface using a combination of nodes and parameters, the sine function in the graph mapper. The video also shows how to adjust thickness, angle, point, count, width, and length to change the shape of the surface. BeeGraphy approach allows a high degree of flexibility to control the design process. We'll start by defining our design space with a range input node. This node allows us to define a range of values for the parameter. We'll set it to a value of a minimum 20 and a maximum of 80. Call this node length. Next, we'll use a line stdl node. This node allows us to create a line using its starting point and direction. We'll use this node to create a line aligned with the y vector. Then give it a start point using the construct point node. Now we will use a range input node to control the distance of each row from the other and call this parameter width, giving it a minimum value of 50 and a maximum value of 150. Then we will incorporate another range input node called count to control the exact number of copies generated within the array. The division will then calculate the appropriate spacing by dividing the total width by the number of copies. Now we will use a node that will allow us to join the resulting nodes into what we call a line array. And the vector x node will determine their direction and distance. To introduce some variation, we'll add points along each line at specific intervals. A point on curve node will allow us to achieve this, placing points at different positions based on the curve's parameter. The specific range of graph mapper numbers is defined by the list sequence SEC node. This node creates a list of numbers in the specified range, and then we have to give it a start, end, and the count we set. Using the graph mapper node allows us to remap a set of numbers using various mathematical functions, giving us control over the distribution of points. We can fine-tune the output of the graph mapper using a Remap Numbers node. This node allows us to adjust the minimum and maximum values of the numbers. Here we also have the opposite node, which will give us the negative value of the data. Since our design involves rotation, we'll need to convert the degree values to radians. This is easily done using an degtorad node, which converts between degrees and radians. We'll rotate each line using a rotate node. This node rotates geometry around a specified center and axis. In our case, we'll rotate around the vector x using the points we created earlier as rotation centers. Now, we will demonstrate the power of Graph Mapper. With our lines rotated, we'll transform them into a surface using an extrude curve node. This node extrudes curves along a chosen direction and distance, creating surfaces. The extrusion direction in this case will be the z-axis, which is defined by a vector z node. This node creates a vector pointing in the z direction. To control the thickness of the surface, we'll use the range input node called thickness by multiplying it by 0.8. We can add depth to our design by extrude surface node. The extrude surface node allows us to achieve this by creating a solid from a surface. The direction of the extrusion will be along the x-axis, which is defined by the vector x node that our multiplication joins to. Finally, to visualize our design, we'll apply material properties using an apply material node. This node allows us to control the appearance of the geometry by adjusting parameters such as color, metallicity, roughness, and opacity. The save camera position function is to show the user the image we get from the position we want. Now let's activate the demo from the menu to the right and see our model. Thanks for watching. We hope this tutorial helped. For more on computational design, please like this video, subscribe to our channel, and hit the bell icon to get the notifications. See you in the next tutorial.